If you run security assessments on Microsoft Azure, this video is for you. Basically, there are native services like Azure Resource Group Explorer, which you can combine with KQL to run queries and understand what are your publicly exposed resources, how you can use that information to investigate perhaps some of the common misconfigurations that you may be finding across your Azure subscription. For this, we have Katie Knowles from Datadog who's going to walk you through how to set up an environment which you can test using KQL and Azure Resource Group Explorer to do a security assessment of your Azure subscription. Now, this video was created as part of the Advent of Cloud Security by Cloud Security Podcast, so you can also find this on advent.cloudsecuritypodcast.tv. But for now, let's get into the video and learn from Katie Knowles on how you can do security assessments of Azure environments using Azure Resource Group Explorer. Let's get into the video.
Hey, how's it going? Happy holidays. My name is Katie Knowles. I'm an Azure security researcher. I really enjoy the research side of Azure, but something that helped me so much when I was a Defender was the ability to do my own Azure security reviews for free. This didn't require any fancy tools or pen test tools, red team tools. You get the picture. I didn't need to code or script anything on my own. This just used a database called the Azure Resource Graph that's available in the Azure portal to query resources and create different reports. I'll take you over to that view right now. I'm really excited to share this one with you. All right, so on the left, we've got the GitHub project where you can find all the files related to this. I'll be providing a link to this. If you can't find it otherwise, it's here. And what this will do is provide you with a bunch of Terraform code that you can use to create your own test environment. This is the same environment we'll be querying during this video. If you don't want to create it, that's fine too. You can always use these queries against an environment that you do have access to, either a test one or production. There's no risk of modifying resources with this, and it shouldn't generate any malicious logs. I've split the files out into a lot of different ones showing each different resource creation. And if you're new to Terraform, I'm hoping this will make it a little bit more approachable for you to run these files. Maybe it'll be the first Terraform you run, who knows? Outside of that, we've got all the queries on this page as well. We'll be going through them in more detail, but you can reference them in the future or on the job in here. The cost of running this shouldn't be too high, and the time that I was playing with it, the few hours I had it running, it was definitely below $5. Just remember to clean up when you're done, which would be Terraform Destroy. We'll talk about that more. For now, let's go over to VS Code. So we've got the project here. I've created my own copy, obviously. We can see that this has some local files that we'll create, or some local variables, I should say, related to the configuration of our VMs. This is used in the configuration to set what ports are exposed, what images we're using, things like that. Whether our storage is exposed, whether our Cosmos DB is exposed, all that kind of stuff. We've also got some random stuff. We need to set a password for our VM, obviously. We need to have some random variables for things that are globally available. I won't go through all the resource creations, but what you need to know is that the VM file will create two different VMs, one Windows and one Linux. They'll have different types of network exposures. Same with the storage. It'll create 3 storage accounts that, again, different network exposure, different rules. We'll look at that a little bit more from the querying side. A couple of Cosmos DB instances. If you're in a hurry, I recommend you just remove this file. Just delete it or move it out of the folder that says Terraform before you run your Terraform apply, because it can take up to 5 minutes to create these resources and up to 20 minutes to delete them. So you really might want to go make a cup of coffee when cleaning up or do something else. We've also got some outputs that'll be displayed at the end of the Terraform run. If you want to learn more about Terraform, there's been some really good content on this earlier in the series, so I recommend checking that out. For now, we're going to move into the Terraform directory. We'll see that all of our Terraform files are there, and if we run a Terraform init, we'll be able to get all the dependencies we need to create these resources within the Azure portal. Something I should mention as well is that I've done an AZ login to the account that has the ability to create resources in the subscription I'll be using for this. So just make sure you do that prior to running this. We'll run our Terraform apply. This is going to check out all of the resources that need to be created. You'll also notice that it's fetching an IP. The Icon Has IP website will give you your IP really quickly. I just use this to assign a network rule to one of the storage accounts. You can remove it if you don't like it. That's all there is to it. We're going to say yes because we want to create all of this stuff. And Honestly, this process can take a little while, so I'll come back in a few minutes and show you the fully baked environment. We're back at it. You'll notice as a result of the Terraform we've just run, we have the outcome of the resource group name that everything was created in. We also have a URL we can use to access everything. For me, I'm going to hop right over to the resource groups, and you can see that this KQL demo environment resource group is now available to us. Just another note, it did take about 5 minutes for all of this to create. There's a lot of status updates you'll get from Terraform, so you'll always know where it's at, but probably a good idea to make a cup of tea or coffee while this one sets up. All right, if we take a look at the resources that were created, we can see that we've got our Cosmos DB instances, the network interfaces for the VMs, the network security groups for the VMs, the disks for the VMs, the public IP address. You can realize there's a lot of resources that go into making a VM. And figuring out the associations between these can be one of the most frustrating things as a defender. You want to know, is this VM exposed to the public internet? Can somebody try to brute force the RDP login? Is there a vulnerability that could be exploited in SSH? It's just not obvious. Even from looking, you can see a public IP won't tell you the network security rules associated with that IP. And it also won't tell you what VM it's associated to if you're looking outside of the Azure portal, of course, if you're just querying this information on your own. We're going to solve that today as one of our challenges. We've also got obviously our virtual machines themselves, but our storage accounts along with the Cosmos DB that we talked about earlier. So on the left, you can see again just the project where all of this is documented. And if we go down to the KQL security review queries, we've got a series of incremental queries we'll be looking at in the Azure Resource Graph Explorer to kind of build on how the KQL queries for these resources work. For those of you who are familiar with KQL, just as a heads up, not every operation that's available in standard KQL is available in the Resource Graph Explorer. So there are some situations where we might use something like a join in a scenario where you would have thought, why can't we use a variable there? Reason being, we just can't use that here. But what's available to us is still super powerful. Love to play with it. So to get to the Resource Graph Explorer, we can type it in. If it's not already in your autocomplete, the Resource Graph Explorer, and open that up in a new tab. And we can see we've got this query pane where we'll be making our queries. In the left, there's a bunch of reference queries. I don't use these very often, but there's some really cool ones. And we will be looking at some sample queries from Microsoft as well as part of this. So we're going to start out by looking at those virtual machines we just talked about. Let's list all the resources, maybe all the resources that are in this environment. How can we do that? So we're going to say resources where I've got a query further down here where we talk about resource groups. Yes, where resource group equals the KQL demo environment resource group. Now, I know this seems pretty basic. For me, I'm constantly forgetting the equals equals or equals tilde. I use them pretty interchangeably here, and I want to be very deliberate about that so that you're aware there's a lot of different ways to get to the end goals here. We don't need to be particularly finicky about our syntax. We're just looking at everything we've got. So we can see the 17 resources that we have in our resource group here. If you scroll over, you can see the details of those resources as well. This is a fantastic way to start exploring the portal a bit more. You can get the identity of a resource, the name of it, the type, you can see all the parameters, but you can also see the properties, and you can query on those properties. This is where it gets really powerful. We have the ability to query our infrastructure at scale, including the properties that are non-sensitive that Microsoft allows us to query, which is still a pretty good amount. So closing out of this, let's go back to the virtual machines. So we've looked at where that resource group is applicable. Let's just look at our compute resources. Maybe I'm remembering that, oh, virtual machines have something to do with compute, but I can't remember the full name. This is the resource provider for the virtual machine. All right, so we've got our Microsoft Compute right here, and we can see that this is listing out every compute that is available to us in this environment, along with the disks. We don't really care about the disks, do we? But they're part of the infrastructure that we're seeing because they are the service provider or the resource provider for them is considered the Microsoft.compute/disks resource. That's how it's addressed in the back end of Azure, which you can also see in the JSON for that resource. So let's take a look at that now. If we go to the disk that we were just seeing, and we take a look at the JSON view, which is always available right up here in this JSON view button for pretty much every resource. This is fantastic because it lets you see how Azure thinks about the resource. It's like, oh yeah, that disk, I call it Microsoft Compute/disks, but you can call it a disk in the interface if you want to, if that pleases you. But we can also see all the properties at once without going through all the clicky menus. We can see that it provisioned successfully when it was created. Public network access enabled. That isn't a query we're going over here, but that's interesting. So you'll start to see there's some properties that we might want to look at a little bit more in depth. For now, let's switch over to looking at just virtual machines. Run the query, and here we go. Just our two virtual machines are showing up now. We've got the Windows VM and the Linux VM. So that was our second query. Our third one is maybe our hygiene team or our vulnerability team wants to know what are all the public IPs available in Azure. So we're going to run a report, and I am jumping ahead a little bit too far. Let's just see if we can find these public IP addresses first. That quote is something I will go and take out before you get to this video. No test environment is safe. So here we can see a couple of public IPs that are associated with our VMs. Looking at the properties, we'll see that this, okay, the properties IP address. Okay, so this is one of our public IPs that we now have assigned to us. We could potentially give this to a team to scan if they needed a list of IPs. We could start poking at it if we wanted to confirm if it was not safe. Publicly exposed, maybe vulnerable. So we're going to add to this query and say where the properties IP address, yeah, not where, but we're going to project. That's what we're doing here. So where will allow you to add conditions to things. You can keep adding these lines and just say where it's exposed to the internet, where the name has Bob, all kinds of cool stuff. You can also always add them as and. So, and name contains Bob, things like that. The reason that I like adding them like this, it's just easier to read. It's easier for you to read in the project. It's easier for me to read on the screen. So a lot of the times I'll just do it like that. But you can use and here. Project, on the other hand, will create a table of information for us. So if we run this, we are still wrong. It's still invalid. Let's see here. Run the query, look at the properties, properties.ip address. Perfect, and it's working. Honestly, I'm not sure what went wrong here. It might have been the API hating me, but regardless, we've got our list. So at this point, if I had 500 VMs or 10,000 VMs, first of all, I might get rate limited while querying this. Just as a heads up, you will be rate limited on the amount of queries you can make against this data and how much it will return. But on the other hand, we've now got our IP inventory. So I can download that as a CSV and give it to our team. The next query I want to build on comes from Microsoft. So there's actually a whole bunch of Microsoft Resource Graph queries that you can use for understanding your own environment. There's some really good starter queries. They're pretty basic, kind of the sort of stuff we already went over. But if you look at the advanced queries, I always find a lot of situations here where I wouldn't really know how to phrase these on my own. I've also used ChatGPT to talk through some of these before. It'll sometimes get it wrong. It'll assume there's functions available that aren't, but one of the later queries in this, I actually was able to set up a couple of joins, and it's really cool to see the results of that query for our final Cosmos DB example. So we're going to take the example query for mapping public IPs to their matching VMs, which I believe should be right over here. So list virtual machines with their network interface and public IP. We're just going to copy that, paste that, run that. Amazing. So here we can see we've got a couple of joins going on, which is pretty crazy. So we're taking the virtual machines, we're combining them with the network interfaces and the public IP address, and that's the final data. So you can see here that we've got public IP and the public IP resource ID, which is really good if you're working with administrators. They love that concrete, what's the subscription, the resource group, the identity of that resource. And we've also got the VM name. So this is really good if we want to say, okay, now we know the public IPs and the VMs that they're associated to. This is huge. Honestly, I spent so much time trying to figure this out in incident response. But what if we build on that? What I want to do is understand not just the IPs for these VMs. I want to know just the network exposed VMs and what their IPs are. So let's start building that. I'm going to start with a second query where we're going to try and understand the network security group rules. Here you can see we've got a query where we are going to, it's probably easier if I show you in the portal. If we put this in, we've got our network security groups, so where the security rules are defined. And we're going to include here looking at the security rules individually. So this MV expand will help us go through the different entries of security rules that each VM has, the access control list, so the ACLs that are there if you're more familiar with that term, and it'll let us match on the direction allow, or the action allow, the direction inbound, and the destination of anything. So VMs that are going to allow traffic in from anywhere. And we can see when we run this query that there's a couple of different rules like this. There's an allow 443 and allow 3389. These aren't the greatest, right? So one of them allows web. Maybe that's good, maybe that's expected. This one though would be RDP, so we might be worried about that one. But we've been able to create this report where we have this listed out again, and we can download it as CSV, share it around, all those good things. One thing I want to mention to you is that if you go into the details of the results of a query like this, where you've used the project function, that will eliminate any fields that aren't specified in that project line. So here you can see we only get the ID, the rule name, the resource group, things like that. It's very good for the table information that we have, but it's not the greatest for these situations where we still want to know all the information we can about the resource. So in those scenarios, we would want to take this row out for our final report. This makes the export look pretty, right? But we don't necessarily need it if we're still tweaking things and we want to know more about these VMs versus going into the details about things. Now this will still have some of the information depending on the way the query is done. So here for the VM NSG, we can see lots of details about it. But if we were to join this data around, the fields that were joined would be maybe the ones that we see and not every resource at once. It's still just a database. Just a little heads up there. Cool. So we've got our general ability to search for network rules. And this allows us to, first of all, know which VMs we need to be paying attention to. If I have 500 VMs, if I have 5,000 VMs, I only want to be looking at the ones that matter in terms of a risk context, right? So which of them have ports exposed to the public internet? That's going to be a big issue. And this query lets us find that very quickly. Now, if we could only associate that back to the virtual machines, right? This next query, it's a bit of a whopper, but it works with the query that we went over before from Microsoft, where we could associate the network security groups and, well, not the network security groups, but we had the network security, we had the IPs and the network interfaces for our VMs through here. And this query will help us combine a little bit of that knowledge. So we're going to take our network security rules and be able to combine them with the IPs, the public IPs, and the VMs that they're attached to for final report. Cool. That actually worked on the first try. There's a couple more quotes I need to remove from this project before you get to it, but don't worry about that. We can see from this query with all of its crazy joins, which I recommend playing with if you're not familiar, we can see the subscription ID, resource group, the VM name, the name of the network interface, the name of the network security group, and then which rule detected for this condition of allowing traffic from the public internet. This, to me, is gold. I can run this in my environment, no matter how big it is, and download it as a CSV and start working in spreadsheets like we all love to, with different security teams to investigate and potentially remediate any of these issues. The fact that the port is broken out as well means that I can filter on what might be a higher risk concern for us to start remediating, that we really don't want to let this go untouched over the holiday break or into the new year. Cool. That was our look at VMs. It's honestly the longest one that we have, so I recommend sticking around for the other activities. The storage accounts, pretty basic. Again, we're just going to run a query, look at our storage. We've got a few that are unrelated. So in this case, again, we want to make sure we're looking at the resource group as well, so that we're not looking at any log forwarding or other storage that's in your environment. So you can see the resource group here. We know that we're looking at the storage we care about. We want to start out by looking at what allows public network access. If we go to the details of this resource into the properties, we can see that public network access enabled is an option for us. So let's just start out by adding that one in. We're going to close this out, put our new query for properties.public network access is enabled. And again, that properties is just this little box down here. You just have to use that dot whatever JSON within here. And we can see that 2 of our 3 storage accounts have public network access enabled. So one of them we honestly don't really care about. It's probably not a risk. It has public network access disabled. It is likely not exposed to the public internet. The other 2, they look a little concerning, right? But if we start scrolling through here, we can see that the one of them, it just says that action is allow. That doesn't sound too great. If we look at the next one, oh, this has an IP rule. So this storage account actually wouldn't allow access from the entire internet. And if we went to our security team and said, hey, this storage account allows access from the public internet, and then they looked at it and said, no, it's just one person's IP. It's not a big deal. They might get really bugged. So let's try and get rid of that. We're going to add this aspect of where the network ACLs have a default action of allow. So you notice in the second one where there is that IP rule, the default action is set to deny. So only the IPs that are allowed through. The deny is going to be the default for most of the world. So by running this check on just allow, we can see that I might have a typo. Oh, but apparently not. This API really just doesn't like a query sometimes. So here we've got just the one with, let me see, default action allow. So this is the one storage account that's actually has public network exposure. And again, we can run this across as many resources as we want to understand it. This, though, this is not a pretty report. I want to be able to get this to a CSV, put it in a spreadsheet of choice, either M365 or Google, depending on who I'm working with, and make it pretty. So this table will let us show what subscription ID, resource group, the name, and all those properties we talked about before. If we click the details, we can see because we used that project, again, we only get what was part of the information that we included in our table. But our table is pretty nice. And here, I actually removed the condition to just look at things with public network, the network access that's completely public, so that allow. And I replaced it with listing out the IP rules. So maybe we want to do a bigger audit on every VM. What are the network rules for every VM? This will at least provide something that we can start to parse out a little bit more to look at which IPs are going to be the ones that are overexposed, right? Maybe somebody allowed a whole bunch of IPs or a very suspicious IP. Now we can start looking at that too. Or we can add that filter from before, just get our list of public network exposure and be done with it. Our final example that I want to touch on has to do with Cosmos DB. So we can obviously look at the Cosmos DB resources like so. And if you do a shift enter, you can run your queries that way as well. So here they are, our Cosmos DB instances. We can start thinking about, okay, where's the public network access? Maybe I'm worried about that. Query on that and see that, no way, only one of them's public. It's like a demo lab. But if we want to get a little bit more specific, we can think of an example. So a couple of years ago, Wiz released a security report on a vulnerability they called Chaos DB. It was really cool research. They were able to get access to the information and the keys of a lot of Cosmos DB instances. They didn't do anything bad with it, but part of their remediation guidance was that they didn't have any proof whether an attacker did this or not. And if you look at the what needs to be done for this, the link exactly to this header isn't working out the greatest, but we can see this short-term immediate steps. Replace your Cosmos DB's primary keys. And this is just a rotation. You don't manually put a key in there. Most of the time you just slap rotate. But oh my gosh, I don't know about you, but that sounds like a lot of work to delegate, and I wouldn't even know where to start. This is a situation, as an example, where KQL can come in really handy with the Resource Graph Explorer. So not only are we starting to audit the security of our environment a little bit, we're also able to help in a pinch. Maybe we've got this situation come up again. I don't know how this would happen again. I really hope it doesn't. But if it ever did, we can say, okay, what are the Cosmos DB instances that we have, and what keys do they have associated? If we look at the details of these, we can see that under the properties, we have some key information, hopefully. Yes, the keys metadata. And we have a lot of different keys here, but you can see that they were generated when it was created. But maybe these are older instances. They were generated way back when Wiz did this research, and they haven't been rotated yet. And there's like 4 of these keys. So I am going to want to check all of them just to be safe. We'll start out by asking for that key metadata right over here. And we can see now in one of our columns, since we put it in our project statement, right? The key data is now under this, but this really isn't the greatest. I can't read this very well. I don't like JSON in my CSV. I don't know about you. We can click the resource, but this isn't very reportable. It's a little bit more effort, but something that we can do is we know that there's going to be those 4 keys, so we can just write it out. All right, cool. This one worked out. So at least for these 3 keys and the 4th coming up in a change to this repository coming soon, we've got the date that each of these was last rotated. So again, this is a great spreadsheet. I hate that I have to say that, but it's a wonderful spreadsheet, right? We have the name of the resource, subscription ID. So if we look at subscription ID owners, we have that. Something else to mention is if there's tags on your resources, you can include those too. So if you're tagged with the owner, you can put that in this report. Resource group name, public access, maybe we want to prioritize ones that we think might be more at risk. Last time they were rotated. Awesome. Download that CSV, and there you go. That's everything that I had. So just to recap, we've gone through querying VMs, which was a bit of a labyrinth, right? And then we touched on querying our storage accounts and showing which ones are actually exposed to the public internet, which VMs are actually exposed to the public internet, and which Cosmos is exposed to the internet, but also how we would potentially get an inventory of what needs remediation during an incident, or looking into somebody else's incident, wanting to make sure that we aren't vulnerable to research that's been coming out, things like that. At the bottom of the repository, I've got links to the Azure Resource Graph Explorer, obviously. You can also make these queries from the CLI if that is what you like. I've got the overview of the Resource Graph Explorer, some starter queries, the advanced queries, and aside from that, I hope this has been helpful to you. Enjoy running it against your environment, enjoy running it against your actual environment, not just your demo environment. I really hope that it gives you the little bit of uplift that your environment might need. So one last thing to mention, just remember when you're done with this to go and do a Terraform destroy. We really don't want to leave these resources running for a long time. They're super cheap to run for a couple of hours, but if you leave them running, obviously the costs will add up a lot. So I'm just going to type yes on destroying all of these. I'm going to wait my 20 minutes for Cosmos DB to finish up. Maybe I'll have a cup of cocoa, celebrate the holiday season, and I hope you have a really great day. Thanks for joining me on this journey. See ya.